Okay, let's do problem 15 threesome. Here we are given an integer array of numbers and we have to find the triplet that add up to 0. So example 1, we can see that -1, -1, and 2 add up to 0, and -1, 0, and 1 add up to 0 as well. So we return that as list of list integers. And example 2, we don't have any triplets, so we just return empty list. And we are not allowed to have any duplicate triplets. So meaning that if you have -1, -1, 2, we can't really have another -1, -2. Right, so suppose we have the 7 numbers here. The most obvious way to solve this one would be having 3 for loops. So I equals 0, and the next one would be j equals I plus 1, and then the next one would be k equals I plus 2. And then we can just literally find all the possible triplets we can have and then find the ones that add up to 0. But again, we don't want to do that because it's like a brute force solution, so it's very time consuming, and even space complexity wise it's not really efficient. So let's just write down what we need to do, just the most obvious one. We have to prevent duplicates, and then we have to find a triplet or triplets. So what should we do? The best way to do this would be first of all sorting an array. So the reason we sort an array is if the numbers are like -3 and -3, and then suppose we have like all the other numbers here, what we can do is we can iterate the nums array, and then after looking at the first one, and then we are going to move on to the second one, what we can just say is if the current number is equal to the previous one, we just continue our for loop, meaning that we skip. So that would be the method for skipping and preventing duplicates. So we do need a for loop. So prevent duplicates is what we're going to do initially. So what's our next step? What's the logic? Well, we have to think about a very simple mathematics, which is a plus b plus c is 0. So assuming the value at I is a, we have to find b and c. So what does b and c have to be? So b and c basically have to be minus a, which is a simple equation. So inside the for loop, we have to find all the possible values of b and c that becomes minus a. So what should we do? So assuming our I is here, what we're going to do is we're going to put pointer left and then pointer right. And then we're literally going to add those two up. And if the sum of those two values are smaller than the target sum we are trying to get, which is minus a, if it's smaller, that means we have to move our left pointer to the right side so that our sum becomes bigger. Okay. So otherwise we have to decrement our r. So here we do need a while loop, because for 2 pointers L and R we always use a while loop, which is L is smaller than R. And what we're going to do is we do need an if statement saying that the value at R, L, plus value at R, if it's smaller than minus the value at I, what do we do? If it's smaller, we have to make it bigger. So we are going to increment our left pointer so that the values we're looking at are much bigger. Else, if the value at R plus value at L is greater than the value at minus A. The reason I called it minus A was because A plus B plus C is 0, and I said the value at I is A, so B plus C is minus I, so that's the value we are trying to get. In that case, we have to decrement our right pointer so that our sum becomes smaller, and then else, meaning that if they're equal, we are going to put that put 3 numbers in our list of lists, so it has to be array start as list, and we have to decrement our right pointer and then increment our left pointer. So that's the way we do it. And then just give a quick example. Suppose we have minus 6, and then we have 1, 2, 3, 3, 4, and 5. So our I pointer is at A, so our for loop, which is I equals 0, so we start with this number. So we do know that we have to find the value, 2 values that add up to 6. So L and R are pointing to 5 and 1, so they do add up to 6, so we are going to add those, the values that are, all the pointers are pointing into our list. And then we are going to move our L and R like this, and then again they add up to 6, so we are going to again put a minus 6, 2, and 4 into our list. So that's pretty much it. Also there's one specific case, well, it's not really specific, but there's a certain case we have to think of. So suppose we are like a multiple numbers, and then we have a minus 6, and then there was a minus 6, like multiple times, right? And we do not really want to, so I will be here initially. So we do not really want I to move to the next one and then work out all of them and then repeat that until we see another number. It will be very time inefficient. So instead of just finishing like this, we can just write down another while loop saying that if the value, the value I left is equal to value, the next value. So if the value, so there should be while the value L left is equal to value at left plus 1, we can just keep incrementing left. And then we can do the same thing for the right hand side. Alright, so let's do it. So here we do need a list of list integer, we're gonna call it 3 sum result equals new array list, and then we're gonna start with our for loop. So for int I equals 0, and then I is less than num star length, and then I plus plus. And here we're gonna check, we're gonna have some statement to prevent duplicates. So how do we prevent duplicates? Well, we can just say if the nums.I is equal to, which is our current number, is equal to the nums.I minus 1, which is the one before, we just want to continue. We don't really want to do anything at all, because no matter what we're going to do, it's going to be a duplicate. And there can be another condition here, because when we start initially I is 0, and then there is no nums minus 1, so we need to put I is greater than 0. Okay. And we do need our while loop here, and before we do that we have to write down our left pointer. It's gonna be the one after I, so it's gonna be I plus 1, and then we are going to have right pointer, which is num start length -1. And we can probably write down our target sum. What's our target sum? Target sum is -I. So the num start I minus. Right, so our iteration will be L is less than R, and we can say if the num start, we can probably have another variable here, which is current sum, which is num start L plus num start R. The reason I'm doing this is because we're going to use current sum twice. So if current sum is smaller than target sum, we have to increase our current sum. To do that, we have to move our left pointer by up. Else, if our current sum is greater than target sum, we have to reduce our current sum, so it's going to be R minus minus. Else, we have to add the three numbers that 3 pointers are pointing. So it will be 3 sum result dot add. What are we going to add? 3 values, but we have to add them as a list. So arrays to list. Oh yeah, we also forgot to sort the array, which was the very important part. Array to arrays.sort. Nice. Almost failed the entire program. Arrays to list. It will be num start I, and then num start left, and then num start R. And what are we gonna do next? We can decrement our counter, increment our L, and then decrement our R. And even before that, we can have a while loop, 2 while loops. So while left, the value I met left, so num start L is equal to num start L plus 1, because if the next one is same, we are going to actually we don't even need the curly brackets for this, so we're just going to do L plus plus. And in fact, there should be another condition. L shouldn't go beyond R. L is less than R. And while, we can do the same thing, while R is less than L, R is greater than L, and num start R is equal to the next value, which is num start R minus 1. We just decrement our R. And at the end, we just return 3 sum result. Okay, let's quickly check the condition. So we did sort the array, and we iterate all the nums, and we prevented duplicates. And this one, L, R, target sum. So while L is smaller than R, okay, current sum, target sum, and then arrays to list. Okay, so let's run the test. Okay, something failed. Arrays. Okay, let's run again. Oh, it's an uppercase. Such a silly mistake. Arrays dot as list. Okay, it's passed, and let's submit. Okay, it's 93%. When I ran it, it was a bit like 99%, I think, but it also depends on the internet speed. Yeah, so yeah, I'm happy with the result. Right, so that's it.